Okay, so these are the bonds we're comparing. Okay, carbon-carbon, carbon-hydrogen, and we're looking exclusively at the energy term here. Okay, so it's 413 kilojoules per mole versus 348. This would be lower on the curve if I was drawing curves for two of these things. Okay, versus this curve. Another way to think about maybe why this is negative is I'm going from, I want maybe products minus reactants, and you can think of the product here as sort of this very minimum low energy state minus some higher energy state would be a negative term. That helps. Okay. So, I forgot. I drew these myself on PowerPoint, so they're not great. But if you want to draw the curve, okay? So you would find the point for 109 and 413, right? For approximate 109. And then similar shape, right? You expect the same kind of shape, the same general thing. Make sure the minimum is at this intersection. Same thing here. Lovely, lovely PowerPoint drawings. Okay. So, a way to think about the bond energy tables, these are the energy you have to put in to break that bond. So maybe one way to think about it. Is our length and energy always tied 1-to-1? Is the shortest bond always the strongest bond? Not necessarily. I'm seeing some head shaking though, and so I bring that up just because occasionally if I do ask a question where I'm asking you to compare and give an explanation, I've had some people who, rather than talking about the energy, focused exclusively on the bond length. And the energy term is one that is better to look at. Okay, if I'm asking you which takes more energy to break, read off the energy value. Do not talk to me about length necessarily. Okay, so that won't always be true. And size is a contributing factor here. Carbon's bigger than hydrogen. They have to be further apart from each other. They don't have a choice. So we saw most of this before, bond energy or bond enthalpy, a measure of bond strength. Okay? It is the energy needed to break 1 mole of that bonded chemical species. So if I had a mole of carbon hydrogens hanging out, this is how many kilojoules it would take to break every single one of those. Okay, right? 6.022 times 10 to the 23rd CH bonds. Okay, it's not really practical to talk about a magnitude of joules that's that tiny when we think about just one. So we're talking about if we had a whole mole of it. Bond strength is correlated to both bond order, single, double, triple, and bond length. Okay, and again, like I said, think about sort of a relative range for these lengths. Think about sort of relatively how length and strength are tied to each other, but they're not perfectly 1-to-1. But generally, shorter bonds, here's a better way to say it. Stronger bonds act over a shorter range, generally speaking. There we go. I should just read my own slide. Generally speaking, shorter bonds are stronger bonds. And here's a nice link I like for more so.